SV Math Teach back again, this time introducing systems of equations. Now, if you're in Algebra 2, like I think you are, you know what a system of equation is. A little reminder of some phrasing. When you have a two-equation system, you will either have a system that is consistent or inconsistent. Consistent systems have solutions, and they either have one solution, which makes them also independent, so you'd say they were consistent and independent, or they have infinitely many solutions, and you would say they're consistent and dependent, like one depends upon the other. If there is no solution, you would just say it's inconsistent, and then you don't have another word to describe it. It's just inconsistent. I have three examples drawn down here. The first example on the left is two lines, the blue and the red, representing linear functions. And because they cross at exactly one point, there is one solution. That would make it a consistent, independent system. The middle example, as you can see, those two lines, two functions, they have the same slope. There's no solution. We would call those inconsistent. And the last one, the blue and the red are meant to try and represent purple. The purple is kind of the overlap of the two. So there's a solution. In fact, there's infinitely many solutions as long as you are on that line. So we would call that a consistent dependent system. All right, simple enough. Now I have one example. The objective of this particular topic is to solve with tables and graphs. And I got to be honest, I find solving with tables wildly inconvenient. Frankly, even solving with graphs isn't all that great either. It's very visual, which is nice, but I typically go with something that's more algebraic. I like graphing calculators for this. I like Desmos is awesome. If you have that sort of technology, Desmos is pretty great. But I'm going to show it here by hand so that you understand the concept one more time. So let's start with the first equation. I'm simply going to graph the representation of all solutions that satisfy that equation. So y equals 3x plus 4. So I start with my plus 4 is 4 on the y-axis. That's my y-intercept. And my slope is 3 up and 1 right, or 3 down and 1 left. I'm going to make a series of dots that follow that pattern. I'm going to connect them up as best I can, and that blue line represents all of the ordered pairs that satisfy that first function. Since I have multiple colors, let's go ahead and use them. The second one I'll do in pink. I'm going to start at -6, so 1, 2, 3, 4, 5, 6, -6. So we're going to begin there, and we're going to do a slope of -2. So -2 is 2 down and 1 right, or 2 up and 1 left, 2 up and 1 left. Look at that. This is where they touch. So while I could continue to make more dots and make myself a nice pink line, and we would obviously see where they touch, the truth is the objective here is finding out where they touch. It's not making a pretty picture. The picture is just the way in which you solve the problem. So the solution here, back to black, the solution is where do they touch? Well, this one touches at -2 because we move left from the origin and then down from the origin. So -2, -2. We would say these are consistent and independent if we had to classify them in some way. That is the beginning or introduction to systems of equations.